Hello, you're welcome to today's lesson. I hope you are doing fine. Today we want to talk about pressure and we want to look at the following: meaning of pressure, formula of pressure, the unit of pressure, pressure on solid, pressure on liquid, the principle of transmission of fluid pressure, pressure on gas, that is pressure law. And we're going to study also the effects of pressure, application of pressure, and instruments we use in measuring pressure. We are going to be taking it one after the other. That means that the lesson is going to be broken into parts. So let's see the meaning of pressure. Pressure, when we talk about pressure, what we actually mean by that is the force that is acting per a certain area in a surface or on an object. The force that is acting per unit area is what we call pressure. For instance, if this is a surface and we have a force of this that is acting on it, we have this force pushing on it. This place represents the force acting on it. For us to get the pressure of this surface or this object, you say per unit area. Whenever you hear unit, it means one. Per unit area means one area of the object. So one area means 1 meter squared, because the area of the SI units of area is meter squared. So when we cut out, what it means is that if we cut out 1 meter cube, 1 meter squared from this object, the particular force that is acting on that particular place represents the pressure of, or the pressure acting on this surface. The force per unit area. So no matter the amount of force that is acting on the surface, when you cut out just 1 meter squared of the object and find the exact amount of force that is acting on that particular area, that represents the pressure of the pressure acting on the objects. So that is actually the meaning of pressure. People define pressure. It is easy to maybe cram the definition of pressure, but a lot of people don't actually know exactly what pressure is. And I hope that you now know what it is now. So formally, we define pressure as the force acting per unit area. The force acting per unit area. The force acting per unit area on an object is what we call pressure. We say on because it is always on the surface of the object. Although pressure can be found inside the surface of inside inside an object, like Pressure can be found inside water, but we are referring to when we are talking about pressure on solids, we often talk about the pressure that is acting on surface of it. We will talk about pressure on liquid. So this is just the general definition of pressure, and the formula for pressure is pressure, we said, is force per unit area. So which is force. If you hear per, it means over. So over unit area, you just write area. This is the formula for pressure. Pressure P is equal to force over area. Now the unit of pressure is Newton per meter squared. How do we get it? This one is, force is measured in Newton and area is measured in meter squared. So that becomes Newton over meter squared. This is Newton per meter squared. You can also write it as Nm minus 2. It represents the same thing. Now let's look at some examples. This formula is used to determine the pressure that is acting on a surface. So we are talking about the pressure on solids. The pressure acting on solids. Now let's look at some examples. Example 1. Now let's assume that we have a body, a force of Okay, the question says that a force of 20 Newton is acting on an object with surface area of 2 Newton, 2 meters squared. Surface area of 2 meters squared. This represents the area. Now calculate the pressure on the objects. Now we have our force as 20 Newton and we have our area as 2 Newton. Then it means that our problem is solved. P, pressure, is equal to force over area, which is equal to F over A. Now we can say that this is equal to 20 over 2, where 20 is force and A is 2. So we have 20 divided by 2 is 10. So we have 10 Newton per meter squared. This is the answer. Now let's look at another example. Example 2. A body weighs 10 Newton A body a body weighing 10 Newton Now, a body weighing 10 Newton presses against a surface of 5 Newton, 5 meters squared. Calculate the pressure. Then just imagine somebody that is weighing 10 Newton leaning on you. To calculate the pressure, we have the area, that area of 5 meter squared. So this body or this person that is weighing 10 Newton is laying the body's weight on you, or your body of area 5 meter squared. And the question is, now we should calculate the pressure. To calculate this pressure, we know that force and weight, they have the same units, which means that force and weight are the same. So we can also say that pressure is equal to weight over area. Pressure is weight and over area. So we have 10 Newton over 5 meters squared, and that will give us 2 Newton per meter squared. 2 Newton per meter squared. Now, example 3. A body, a rectangular block with dimension 2 cm, 2 meter by 3 meter, is acted upon by a rectangular block with dimension of 2 meter by 3 meter is acted upon by a force of 24 Newton. Calculate the pressure. How can we calculate this? The dimension is 2 meter by 3 meter, and this is a rectangular block. For us to get the area, we know that the area of a block, of a rectangle, is length times breadth. So we have that the area is equal to 2 times 3. The dimension here given to us is what we use to calculate the area, which gives us 6 meter squared. Now please note that if If the unit of area is given in cm or another unit, we have to convert it to meter, to meter squared, because our standard unit for pressure is Newton per meter squared and not cm. So we have to convert whatever we have to meter squared, or else it's an OBJ and you have seen that the options given to you are in cm. Maybe the unit of the pressure is Newton per cm squared. In that case, you can leave your area unconverted. But if the unit of the pressure given to you is in meter squared, you are required to convert the area from any unit given to you to meter squared. Now this one, we know that P is equal to F over A, which is equal to, our F force is 24 Newton, and dimension now is, area now is 6. So we have 24 over 6, which is equal to 4 Newton per meter squared. So this is how to calculate pressure acting on solids.